everything that we've said also applies to finite intervals. In other words, we've been looking at intervals that go all the way to the left or all the way to the right with only one endpoint. What if we have an interval that's not infinite? It has two endpoints. For example, this interval has -1 as its left endpoint and +2 as its right endpoint. And furthermore, it contains 2, but -1 is left out of the interval. How would we represent that using inequalities? Well, x sort of is represented by our shaded region. Or in this, it would be represented by the comma, everything between. Okay, that sort of motivates the way we're going to write this. That says that 2 is to the right of x and -1 is to the left of x. And I can show that x is able to equal 2 by saying x can be less than or equal to 2. I show that it is not able to be equal to -1 by showing that, or by writing -1 is less than x. So this is the way, using inequalities, we can represent this interval. Well, how are we going to solve something that comes to us in 3 parts? Let's look at an example. If we have 4 is less than 7x plus 6 is less than 20, how are we going to solve this? Well, remember, if we're solving things, whether it's an equation or an inequality, the goal is to isolate the variable. So normally, in an equation, we have some stuff equals some other stuff. Or with an inequality, we have some stuff is less than or whatever, some other stuff. They come in 2 parts, separated by the symbol. Well, now this just comes in 3 parts, separated by 2 symbols. To solve an equation or inequality, so far, we have done the same operation to both sides, or both parts. If we have 3 parts, it's just a matter of doing the same operation to all 3 parts. So, I've got a 7x plus 6. I want to isolate x, so I have to subtract that 6 away. That means I'm going to subtract 6 from all 3 parts of the inequality. So I'll have -2 is less than 7x is less than 14. Now again, here's my x. I'm trying to isolate it. It's multiplied by 7, so I've got to divide by 7. Meaning I'm going to have to divide all 3 parts by 7. And so the result is -2/7 is less than x, which is less than 2. Okay? We could represent this in interval notation as the interval from -2/7 to 2, or in number line notation by marking off, there's 2, 1, -1, and so forth. We're going to go all the way up to 2, and on the left we'll go to -2/7, which is right around there, and we shade between them. Now, what if instead of 4 less than 7x plus 6 is less than 20, what if we had had a -7x? How would this be different? Well, we're still going to subtract 6. We'll just get a -7x here. Now, when we divide, we're going to divide by a -7 because that is our coefficient. And here's what we end up with. we're going to get a positive 2/7 here, and over here we're going to get a negative 2. And also, because we're dividing by a negative, our inequality symbols are going to reverse. So this will no longer be true. This would be our solution to this new inequality. To write that in interval notation, we're not going to write the interval from 2/7 to negative 2. We have to write it in order. So it's helpful if we turn this whole thing around and write negative 2 is less than x, which is less than 2/7. So the interval will be the interval from negative 2 to 2/7, and the graph will be similar. There's roughly 2/7, there's negative 2, and we shade between them. But the point is, first of all, do the same thing to all three parts. Don't let any of your parts disappear. You got to have, if you start with 3 parts in the beginning, you're going to need to have 3 parts in the end. And if you multiply or divide by a negative, you're going to reverse both of your inequality symbols.